This is section 10.1. We're going to look at practice A. We're going to draw two circles with a given number of common tangents. So if you want 3 common tangents, you want your circles to look like that. If you want 2 common tangents, you want your circles to look like that. And then your common tangents would live in those spots. 1 common tangent would look like that. So that's the tangent line for each of those. Okay, next part. In the diagram, segment BC is a radius of circle C. Determine whether segment AB is tangent to circle C. Explain your reasoning. Number 24. Yeah, absolutely. It's tangent because segment CB is perpendicular to segment BA. And that's all you need. If they're perpendicular, then that segment BA is a tangent. Number 25, are they perpendicular? Yeah, they definitely are. This is a 3, 4, 5 right triangle. 3 squared plus 4 squared equals 5 squared. So that is a right angle, which means segment AB is a tangent. Now, when you look at number 26, 3 squared plus 6 squared does not equal 7 squared. This is not a tangent. Okay, I'm not going to do all of these. Maybe we'll just squeeze over and do number 29. Leg squared plus leg squared equals hypotenuse squared. That's r plus 9 squared. And this should be an equals here. Okay, let's solve. You got a binomial squared, so we'll have r squared plus 18r plus 81. Just like in our other examples, those r squareds cancel. So 18r equals whatever 225 minus 81 is. I got a calculator here. Let's see what we got. You should have one too, by the way. 144. Okay, so that works out. And then 1r would be however many times 18 goes into 144. Looks like 8. Okay, so your radius is 8. And that's how you do all of those from that section. I'm going to leave you a couple to do on your own. Next one here, segment JK is a tangent to circle L at point K, and segment JM is tangent to circle L at point M. Find the value of x. So what they're telling you is these are common, or these aren't common tangents. These are tangents that meet at a common point, point J. So x equals 22. So in all of these, you're setting those segments equal. Remember how this goes, guys. Those are congruent too because they're radii. That makes a kite. Do you see the kite? There's the kite. Okay, one more. On a softball field, home plate is 38 feet from the pitching circle. Home plate is about 45.3 feet from a point of tangency on the circle. So hopefully that makes sense to you, what you have there. So this is how far you would be pitching the ball. This segment is tangent to that pitching circle. How far is it from home plate to the point of tangency on the other side of the pitching circle? So it would be like this. How long? Well, that's a terrible picture, but how long is that? It would work the same way as the other side. Remember, you need that kite. So it would also be 45.3 feet. What's the radius of the pitching circle? All right, so you got this situation. This is your radius. This is 45.3, and then this is 38 with that radius added. So radius squared plus 45.3 squared equals r plus 38 squared. And hopefully this works out. That 45.3, I'm pretty sure that's a rounded answer. 45.3 squared is 2052.09. The other side, we're squaring a binomial, so you'd end up with 76r here, plus whatever 38 squared is. 38 squared is 1444. Now, your r squareds cancel. Take the 2052.09 and subtract the 1444. That gives you 608. 608.09. And that's going to equal 76r. Let's just divide that guy by 76. Okay, and just as I expected, I'm going to put the wavy equal sign here, because 8.00 is what you end up with. And the actual answer is a little bit bigger, and it's that way because, remember how I was skeptical of this number at first? That's not exact. So obviously this isn't going to be exact. I'm pretty sure the radius of that pitching circle is 8 feet, and that's how they would measure it if they were to lay out the field.